Welcome back. When we left off, we were talking about the dot product in relation to the angle, the cosine in particular. So let's get back on this and actually take a look at some problems where we're going to use the dot product as and the angle. So in this problem, it says vectors A and B have lengths 4 and 6. So let's see, that means the size of A is 4, the size of B is 6, and the angle between them is pi over 3. We want to find A dot B, the dot product of A and B. So using the formula on this previous slide, we know that the dot product of A and B is the magnitude of A times the magnitude of B times the cosine of the angle. So in this case, I have 4 times 6 times the cosine of pi over 3, which 4 times 6 is 24. The cosine of pi over 3 is 1/2. So this will just be 12 for my dot product. Now, you might have noticed back here that, whoops, not there, right here, that this formula could easily be solved for cosine. And in fact, that's where this is the most useful, this particular aspect of the dot product, that the cosine of an angle, or the angle between two vectors, is just the dot product divided by the product of the magnitudes. So let's go ahead and try this with these two vectors. So the first thing we need to do is to compute the magnitudes. So that's going to be the square root of 2 squared plus 2 squared plus -1 squared, which happens to be 3. And this is going to be the square root of 5 squared plus -3 squared plus 2 squared, which is not quite as nice as the previous one. That's going to be the square root of 38, if my math is right. Let me double check. 29 and 9. Yeah, 38. So now we want the angle between these two vectors. So the cosine of the angle between the vectors is the dot product. Dot product is, I should have written that somewhere, maybe up here. Change the color. A dotted with B is 2 times 5 plus 2 times -3 plus -1 times 2. So that's 10, -6, that's 4, 2. So cosine of the angle is that 2 that we got from the dot product divided by the product of the magnitudes. So 3 times the square root of 38. Whoops, the angle. Oh, there's not much I can do with that, is there? So let's just pull out our calculator and let's see what we get. So I'm going to use my calculator and bear in mind that you want to be in radians. Well, I guess you just need to be aware of your whether you're radians or degrees. But interestingly, it doesn't matter. You don't have to worry about quadrants with cosine, this particular cosine. That's one of the beauties of it, of using this, is there's no worries about, sorry, I've got a parentheses around the denominator here. So there's no worries about whether you're in quadrant 1 or 2 or 3. I got 83, I guess I'm in degrees. 83.79. And let me just find out what that is in radians. So in radians, so that's degrees, or 1.462 radians. All right, very nice. All right, so one of the little facts about this that is also useful is that two vectors are orthogonal if and only if their dot product is 0. Now, you might be looking at that word orthogonal thinking, what in the world does that mean? Let me draw some orthogonal vectors. That vector and this vector are orthogonal. This vector and this vector are orthogonal. So you see that orthogonal just means that they make a right angle with one another. And so all this is saying is that two vectors are orthogonal if and only if the dot product between the vectors is 0. This makes a lot of sense because if you have two vectors like this that are orthogonal, then the angle between them is pi over 2. The cosine of pi over 2 happens to be 0. And so the cosine of the angle, remember, is the dot product divided by the magnitudes. And as long as these aren't zero vectors, like zero length vectors, the magnitudes those will be something. So the only way for this to equal 0 is for the dot product to be 0. So let's just verify this. These two vectors are perpendicular or orthogonal, if we want to use the fancy word. And so we're going to check to see if they are orthogonal. Let's name those A and B. So A dotted with B is 2 times 5 plus 2 times -4 plus -1 times 2. And this is 10 minus 8 minus 2, which is indeed 0. And so these are orthogonal. All right, so I guess this brings us to the next topic, which we'll explore in the next video.